Let's go to page 240, and this is lesson 4.4, and this lesson is about prove triangles congruent by SAS and HL. Okay, so we're going to talk more about this later on. But SAS basically means the side, angle, side. And notice the angle is between the side. So what you have is this situation over here. So you have the side, angle, side. Okay, so when you have a side, angle, side situation, then they are congruent. So if you can get this kind of situation, then they are congruent. So you can, if RS is congruent to UV, and angle R is congruent to angle U, and RT is congruent to UW. And notice angle has to be between the two sides. Okay, angle has to be between the two sides. Then the triangle RST, so RST is congruent to UVW. Again, you have to watch the order of the letters very carefully. You have to match up very carefully. So notice letter R. So letter R is the one with one arc. So you have to match with the one with one arc. So match it with U. The S is the one that's facing the one hash mark. So you have to match with V because V is facing the one hash mark. So T is facing the two hash marks. So W is facing the two hash marks. So that's how you match up the letters, okay? By looking at, if it's an angle, you look for number of arcs. If it's the length, you look for the one that's facing the length. Okay? And so again, make sure you match the letters carefully. Okay, let's go to example 1. It says use the SAS congruence postulate. Write a proof. So giving, again, notice they always give you two information. And then from there, you have to look for the third one. Okay? So BC is congruent to DA. Okay? So you see the hash mark. Okay, so whenever they give you, right, then you put down the hash mark. So that way you can see it clearly that this and this are congruent. Okay? Next one, when they give you the parallel. Okay, so BC is parallel to AD. So you put the little red arrows right over here. See the red arrow? Okay, so that tells you that these are parallel. Now, you have to able to do this automatically. Okay, whenever you have parallel lines, you have to think about alternate interior angles or corresponding angles. Okay, so those are things you have to look for. Okay, in this case, you have to look for alternate interior angles. Okay, and you want to prove that triangle ABC is congruent to CDA. Okay. So what you want to do is, okay, so first BC is congruent to DA. Okay. So that is giving. Okay, because over here. Next, the parallel lines, they are also giving. Okay. Then again, remember what I said, right? Whenever you have parallel lines, think about alternate angles. Okay. So you're going to have the angle BCA. So BCA, that's this angle right over here. Okay, so again, you do the hash mark. So BCA is congruent to DAC. Okay, so you do the hash, do the arcs. Okay, so you can indicate these angles are congruent. Okay. Okay, now remember, after you use up everything, right? Now you use up everything. The things to look for is when you have triangles like next to each other like that, you look for the reflexive. See the AC? So you're going to have the AC is congruent to CA. Now notice the letters are switched. There's a reason for that. Okay? Because, see, for this triangle, the A is facing the one hash mark. For this triangle, C is facing the one hash mark. So that's why the letters are switched, because you're looking for the letter that's facing the one hash mark. Okay. So this is a reflexive, so you can make the hash mark like this. So now you have that. So now you can say this triangle is congruent to this triangle. So you got triangle ABC is congruent to CDA, and the reason for it would be side, angle, side. So that's SAS. So when you write, you can just write SAS. That's good enough. Okay. You don't want to write congruence partial. You can just write down SAS. Okay. Now and again, when you write the letters, you have to make sure you match the letters correctly. So A, so you can write any order for the first one. So once you write that, then you have to try to match the second one with the first one. So this triangle ABC, the A, the A is facing the corner of the vertex A is facing one hash mark. So this will match with the C because C is facing the one hash mark. Now the letter B is facing the two hash marks. So this will match with letter D. So D is facing the two hash marks. Then you go to C. So C is facing the one with no markings. Okay, for this triangle. So for this triangle, the letter A will facing no markings. Okay, or another way you can do it is by looking at the angles. Okay, so and that's it. So again, so you got SAS. Okay, now let's go to page 241, the example 2. So you have this situation. So in a diagram, QS and RP pass through the center M of the circle. So that means those are diameters. That means each of these are radius. What can you conclude about triangle MRS? So MRS and MPQ. Okay, well they would be congruent, okay, because all these are radius, so this would be congruent to that, this would be congruent to that, and I use the same hash mark because they're all congruent. If they are different, they have to use like different number of hash marks. Okay, now remember what I said, right? When you have triangles that's next to each other like that, you look for the reflexive. Okay, you look for AC is congruent to CA. Okay, when you have triangles like corner like this join each other, you have to look for vertical angles. Okay, so we can say that vertical angles are congruent. Okay, so now you have a SAS, right? So that's how you know that they are congruent, because of the SAS. So again, when the two triangles if it have a common vertex over here like this, then you have to look for the vertical angles. When they are like shared one side like this overlapping, then you have to use the reflexive. Okay. So again, usually they give you two information, then you have to get a third one by looking at the picture to get a clue. Okay, so now we deal with triangle that kind of just any kind of triangle. But when you have the right triangle, okay, so here's a right triangle. So the right triangle, here's the right angle over here. The slender side, the longer side is called a hypotenuse. The other two, the perpendicular sides are called leg. Okay, so a right triangle has two legs and a hypotenuse. Okay, so when you have right triangle, the angle is already congruent already. So this term is called HL. So it's hypotenuse and the leg. Okay, so if a hypotenuse are congruent and the leg will be congruent, then they are congruent. And this one, the reason for that is if two sides of the triangles are congruent, it's a right triangle, so you can use a Pythagorean theorem. So you can use a squared plus b squared. So again, you have this side congruent to this, you got this side congruent to this. So you can use Pythagorean theorem, okay, to get the next side. Okay, so that way this is actually came from kind of match with the SSS. So we're going to cover more of this later on. Okay, but again, when you have the right triangle, one of the angle already congruent already. That's why all you need is two more congruence. That's why all you need is two letters. Okay, whereas if it's not a right triangle, then you need to use three letters. So if it's a right triangle, the angle is already congruent, so all you need is two more congruence. So that's why all you need is two more letters. Okay. Okay. So let's go to example 3 on page 242. So giving. Now, when you have this kind of situation, it's kind of confusing for a lot of people. So I would recommend what you do is you go and separate the two, go and slide this and slide it open, okay, so that you will have this kind of situation. So slide this open and so that you get W, Z, Y, and you got X, Z, Y, okay? Okay. So it tells you that, so now you do the marking, right? So WY, that's this one, is congruent to XZ, okay? And it tells you this, the WZ is perpendicular to ZY, and XY is perpendicular to ZY, okay? Okay, so now, so because these are perpendicular, so these are right angle, right? So right now, notice when you slide, again, remember what I said, when you have overlapping or when they butt against each other, you look for reflexive. So you can see that this is equal to that because it's reflexive because this is the same side, right? So again, so that's your HL, right? This is your hypotenuse and that's your leg, right? So hypotenuse, that's your leg. So that's kind of the approach, okay? So again, when you have this kind of situation, you want to slide this open and it's more clear, okay? If you can do it without, then that's fine. But for most of the students, it's easier for them to slide it open and matching things up. Okay. Okay. So solution. So that's what we did, right? Now the steps. Okay. So first giving. Okay. So so first this is congruent to that. So we did that, right? So that's giving. Next perpendicular, we did that. Okay. The next, what we need to do is say that angle Z and angle Y are right angles, okay? And that's definition of perpendicular line, okay? Next, so that this is right triangle, this is right triangle, and that's a definition of a right triangle. Definition of right triangle is when you have a right angle, okay? So now you can use the ZY. So ZY is congruent to YZ. Now again, you have to match the letters carefully, right? Okay, so notice this is from the corner, from the right angle to the other one, right? So this match with this match with that. So that's why the letters are reversed. So you have to pay very close attention with how the letters are matched up. Okay? If you mess up the order of the letter, then it would be incorrect. Okay, so make sure you pay close attention to what letter matches with what letter. Okay, so again, so once they're equal, again you do the two hash marks. Okay. Then after that, you can say the triangle is congruent to this triangle, and the reason for that is HL, right? Okay. And again, match the letters carefully. So you see the W, Y, Z. So usually the first triangle, you want to do an alphabetical order. Okay? So the first triangle, you just do an alphabetical order. Then the second triangle, you try to match up whatever is on the first one. So notice the first triangle, W, is facing the two hash mark. Okay, so that means you match it with the X, okay? Because this match with two hash marks, see that? So X, right? Then the Y is facing no markings. So you match up with Z. Z is facing no markings, see that? That's how it match. And over here, the Z is the right angle, okay? So you match up with the Y, the right angle, okay? So you can match up your letters very carefully. Okay, let's go to example 4. It says choose a postulate or theorem. Okay, sign making. Okay, you are making a canvas sign to hang on the triangular wall. Okay, over the door to the barn shown in the picture. You think you can use two identical triangle sheets of canvas. You know that RP is perpendicular to QS. So if it's perpendicular, that means these are right angle, right? So these are right angle. So it says, what partial theorem can you use to conclude that the triangle PQR is congruent to PRS? Okay, well in this case, notice the RP equal to RP itself, okay? So you can put a hash mark right over here, okay? So you're going to get SAS because the right angles are congruent to each other. So you can use the SAS, the side angle side. Okay, so SAS. But actually later on, okay, I will go over more about this. So another theorem can use that is not covered in this lesson is there's actually a theorem called LL. Okay, so we're going to cover more about different postulates to prove. So actually in this case you can use LL. Okay, so again, we can cover more there. But since we have not covered that yet, so you're just going to use the SAS.